We do go in and educate yards and help them with how anodes work, correct anode application, etc.
This is the Ben Taylor Podcast, the home of marine industry insights. Enjoy. Hi everybody, welcome to another episode of the Ben Taylor Podcast, the home of marine industry insights. This is part of a little series where we're profiling the Australian market about what's going on down under, some of the trends, some of the organisations out here. So today we're with Marine Protection Systems, MPS. I'm here with Jess. Nice to see you, Jess.
Hey Ben, nice to see you. How you doing?
Not bad at all. So give us a little context. What do you guys do? What are you about?
Okay, so Marine Protection Systems is an Australian company that's been in operation for over 15 years, and we specialise in marine corrosion protection.
Okay.
So specifically, we're all about providing and generating innovative products to the marine industry to overcome common problems associated with marine corrosion.
Right, and so corrosion's been around forever.
Forever and ever.
So how do you innovate in that space? What kind of new solutions come up?
Yeah, sure. So typically we're in the anode space, so your cathodic protection space. So traditionally zinc anodes have been around for a couple of hundred years in terms of a marine corrosion solution. Now, there are problems associated with zinc anodes. Now, they're a great anode, they protect against corrosion, but we're all about fixing those problems associated. So most commonly, we're in that overprotection game. So where anodes actually are doing too much of a good job and they cause overprotection. So we get a lot more anode wear, we get a lot of coating failure. And so what we did is we developed a new style of anode, which is a composite alloy, and it's a low voltage anode. So what it means is that we get much better performance out of our anodes, a lot less wastage, and we get retention of coating. So where you often see a lot of coating failure around your through hull fittings and swim platforms and that kind of thing, we have pretty much absolute retention of coatings. We have corrosion protection, but what it means, we're minimising our impact. So we're not putting cuprous-based antifouls into the waterways. We're not putting excessive amounts of heavy metals into the waterways. We're doing it in an approach that's a traditional approach to corrosion protection, but we're doing it in a way where we're reducing all of the effects.
Okay, so essentially as a result,
Yep.
I'm going to say metal things,
Yes, the metal
parts
bits.
are better protected.
Yes.
The actual anode will then last longer as well.
Correct.
And that's important from kind of just a user experience and maintenance side.
Absolutely.
But it's also on kind of the emissions and what's released into the water.
Correct.
Traditional anodes, they actually have some quite harmful metals that
They can do.
as they get used, they end up in the water.
Absolutely.
And they're damaging the environment.
You're exactly right. And so, zinc certainly has its place in the market.
Okay.
Aluminium anodes have their place in the market. We're all about educating the market as to why a low voltage anode.
Well, go on, Chad. Tell me. So, so why would you go zinc over something like aluminium, and then with these low voltage ones, what's the kind of big difference?
So
there?
the number one rule when going, okay, what is the right anode for my boat?
Yeah.
Your first question should always be, what is the metal that I'm protecting?
All right. I was going to say salt water or fresh water, but
okay. So we'll start there. So salt water, absolutely. So if you're in fresh water, you really only have one or two options. You go to a magnesium anode, right? And in some circumstances, you would use an aluminium anode. So they're the very high potential anodes. They're very, very active because you have a very non-conductive electrolyte. Okay?
Help me along with the last
So your
little
water
bit.
is your electrolyte.
Right.
So you need an anode will only work on submerged metals that are in contact with one another.
Right,
so you
okay,
either
and there's
have a
kind of
mechanical connection of an anode to a piece of metal, or you have an electrical connection of an anode to a piece of metal through a bonding system.
Right, okay. And that will work differently in salt water compared to fresh water.
Correct.
Because of how much the water conducts?
Conducts electricity.
Right, okay, yeah.
Because what an anode is it's generating DC voltage.
Okay.
Right, between something more active and something less active.
Yeah, hence you get this kind of sacrificial effect.
Yep.
It's
and so
damaging the anode rather than the metal parts on the boat.
An anode is whatever is most active. So if you have a prop shaft with a propeller, that shaft is a very low potential hard metal, your stainless steel or duplex or something like that.
So does that mean it tends not to get corrosion damage?
It does not get a galvanic corrosion damage. So so on its own, it's not going to suffer from galvanic corrosion, because you only get galvanic corrosion when you have dissimilar metals in contact with one another. So as soon as you put a bronze propeller on, my bronze is now more active. And so my bronze will become the anode to protect the stainless steel shaft.
Right.
So then you put a sacrificial anode in place that's more active again, and it's going to be the anode to protect the propeller and the shaft.
Look at that.
That's
Learn
simple,
new things every day. Right, okay. And
but the difference is an anode is considered an anode by international standards as something that's between 100 to 200 millivolts more active, which isn't a lot. So if you go and put a zinc anode on a bronze propeller, that is overprotecting it nearly 3 times. It's actually providing 3 times more voltage than is needed for an appropriate cathodic protection reaction.
Okay, and take me into this voltage thing, because I'm thinking like batteries, electricity,
it's pretty much
voltage.
A battery.
Like, is that just like a naturally occurring current, or right? Okay, so it's not powered, it's not solar panel, nothing like that.
It's completely passive. Right, and so basically, every metal in seawater will generate a voltage.
Right, okay.
Okay? Now, when you put it in contact with something else that's a different voltage, whatever is more active or more negative,
it's going to attract
will deplete itself to make sure that the other metal that's in contact with becomes the same voltage.
Okay.
So that's why we have wasting of material. It's almost like, you can think of it like an electroplating. It's giving up its ions to protect. And so, in that way, it generates current and voltage.
Right.
The bigger the difference between the cathode, so what the metal is that you're trying to protect, and the anode, the more current flow you get.
Yeah.
And so it has more drive potential. And so in the world of overprotection, what you see is that current is what drives a coating off. And this is something that everyone, all the yards that we've been to around the world, they deal with this problem on a daily.
Right.
They don't necessarily know that it is a result of an anode and cathode reaction, right? And so commonly people will say, oh, that boat's got electrolysis, or that's just how it is. And we come in and we educate a yard or a builder or an operator and say, actually, no,
this is what's happening.
You have a really simple solution. Yeah. One, what metal am I trying to protect? What is the right anode for that solution?
Yeah.
So if you've got a steel yacht, for example, our anode, the Maddox anode, which is a low voltage anode, is not going to be active enough to protect steel. So you need to use zinc or aluminium.
Right, with you.
If you've got an alloy yacht or an aluminum boat.
Different solution, because of the different potentials, different things are occurring.
So aluminium boats are actually best protected by aluminium anodes. Funnily enough, it is a different aluminium. It's a common question that we get asked. It's more active than zinc and is more appropriate when protecting aluminium. So you'll find all your outdrives, so your sail drives, your stern drives, your outboards, now pretty much all come out of factory using aluminium anodes. So Volvo, for example, they now have moved to a completely aluminium solution because it's environmentally friendly and it is going to be more active and more efficient compared to zinc, right? So it's number one, what metal am I trying to protect? We've got excellent resources on our website, which has that anode selection guide. So we have one by each type of waterway, a freshwater solution and a salt or brackish solution. What is my boat? What is the metal that I'm trying to protect? And what is the right anode composition? Maddox is not the right anode for every boat. Maddox is an anode designed for timber and for GRP and carbon when we're protecting hard metals. If you're a GRP boat with a sail drive, you need to be using aluminium anodes. And so all of that's very, very clear in these resources that we've developed, because I could talk to you about the science all day, and sometimes people either don't want to understand, don't need to understand,
it's not going to be everyone's
involved,
it's not going to be everyone's niche. They just kind of want to say, look,
just what do I need?
This is a situation, help me out.
Exactly.
They'll kind of trust in you to say.
Exactly. So really fundamentally what we're about, and all of our product development pipeline is about improving efficiency, minimizing impact on our oceans, and just best practice. right?
Bit of
and
guidance.
So we find globally we have a massive task to do in terms of education. It's the world of corrosion is a bit of a dark art. We have another business that's corrosion consulting, and that's actually what's propelled all of our product development, is finding solutions for things that don't exist in the market.
You're constantly saying, well, here's a solution, you're researching things, and you end up doing R&D work.
Yeah, absolutely. So, you know, like a lot of stray current detection, looking at, you know, we're doing a lot in the e-space, so the electrification of motors and things like that has a massive impact on corrosion and things like that. So the best case for us is to help a builder set up a boat that's correct from day one. It has the opportunity for monitoring. It has the right cathodic protection so that all the risks are realised and that we are providing the best practice for that vessel to promote longevity and to minimise all of that extra work, things having to be cut out and replaced or coatings failing and going into the waterways. What we want is efficient boating and best practice.
Right, and so typically you mentioned working with shipyards. Who would be the people you deal with most, that you help most? Do you work directly with boaters? Is it just in Australia?
How do you operate? At the moment, MPS is very, very established and has been very well established in Australia and New Zealand for a long time. Being an Australian company, I'm a firm believer in getting it right in your backyard.
Right.
You know,
do it right first.
Absolutely.
Like kind of really dominate that.
Get the formula right.
Get it right, get established, and then
expand.
Bring it out, right? Okay,
so the last couple of years we've been in that expansion phase, and last year we set up distribution in the United States.
Okay, cool.
Yeah, and we have some smaller distributors in Europe, but that's all changing. So over the year we'll really start heavily pushing into the European market.
Right, but it's been well received in the market, and in terms of solutions, it's so perfectly applicable worldwide.
Absolutely.
So you become like an Australian company that's exporting and supplying the world.
Our best opportunities really are at the boat builder level.
Right.
So we test a lot of boats in Australia. Boats that are coming in, boats that are built here, and we know where cathodic protection can be improved. Whether it's just fundamentally a boat builder has always done it the same way for a long time and hasn't really thought about how they do their anode design.
Yeah, because they'll be changing materials all the time. So actually the corrosion protection system will also need to evolve.
And often it's like we've got a problem, we think we just do this, and respectfully,
it's a bit more complicated.
It can be a little bit more complicated. So you really need to look at the vessel as a whole. What are all these materials? How do they play into one another? Do I need two separate cathodic protection systems, which is absolutely achievable on a non-conductive hull, right?
Right.
So it's really looking at the boat and setting the boat up for best practice. So our best opportunities are with boat builders, so they know that they have the confidence that as that boat goes into the market, they've done their best, they've got the best products on there, and it's done in a really educated and technical way so they can really stand by and trust and be confident in the product that they're putting out to market. So our key opportunities globally, we want to start with major shipyards. Yes, we do go in and educate yards and help them with how anodes work, correct anode application, etc. But really, the boat builders is a great start. That all being said, we do a lot with individual boat owners that recognise they have a problem and they want to do better. They want a better result. They want their boat to come out of the water and the prop speed's looking amazing. They want to pull the boat out of the water and the swim platform is looking amazing. That's what we want from people. We want them to have a really good experience. We've never known a customer to change to a Maddox protected boat and go, oh no, that really wasn't worth the exercise.
It's very little regret.
Absolutely. Yeah.
Okay, brilliant. Jess, thank you so much for your insight. I've learned a lot. I'm sure many people watching know as well.
Thank you.
So thanks for coming on the podcast.
Really
Thank you for your insights.
Thanks, Ben.
Yeah, you're very, very welcome, Jess.
See you guys.
Everybody, if you find content like this insightful, make sure you're following here to see plenty more of it. All being well, we'll see you again very soon. Bye for now. Thank you for listening to another episode of the Ben Taylor Podcast, the home of marine industry insights. We'll see you again very soon. Bye for now.